very much for the invitation. Thank you very much for being here. My name is Carlos Bravo. I'm from the University of Los Andes in Colombia, and I'm going to talk about this work that we did that is called Disentangling snakebite dynamics in Colombia. How does rainfall and temperature drive snakebite temporal patterns? So to start introducing this topic, something really important is that snakes are a really diverse animal. You can find a lot of shapes and color of different snakes, but not every snake are venomous. There are some snakes, such as this group of snakes where you can find the boas or the anacondas, right? That doesn't have any fangs or venom glands. But on the other hand, you have these two groups of venomous snakes. Here in the tropics, you have the coral snakes from the family Elapidae, but for example, in Africa and in Asia, you have the cobras and the mambas, which are venomous. They have fangs and they have a venom gland, and also you can have the viper snakes, which you can see like the fer-de-lances, the bushmasters, the rattlesnakes, which has also fangs and also they has venom glands. So not all snakes are venomous. The most probable thing is that if you find a snake, it will be a non-venomous snake. But this tiny group of venomous snakes cause this problem, this disease, where we have an estimation of around 1,800,000 cases each year with at least 94,000 deaths. But something important is that snake bites fulfill all the requirements to be treated as a neglected tropical disease. So nowadays, the World Health Organization recognizes snake bites as an NTD, and that's the reason why I am here talking with you about snakes and venomous snakes. If we compare mortality of a snake bite with these other neglected tropical diseases, we can find that it has the first place in deaths. But something that happens with the snake bite is that normally we don't know anything about the natural history, ecology, and basic biology of venomous snakes. For example, for the sandflies in leishmaniasis, or for the water snails in schistosomiasis, or for the kissing bugs in Chagas disease, we know reproductive cycles, we know home range, we know activity patterns, but all of this data is totally unavailable for snake bite here in Latin America. Another thing that happens in snake bite that is transversal to other neglected tropical diseases is underreporting. When a person have a snake bite, it can go to a medical center where the case can be reported, or he can go to seek for traditional medicine where the case will not be reported. So as a consequence, data underestimate disease burden. The treatment of a snake bite is done by antivenom, which is produced by immunizing production animals. So you require a serpentary with veterinary care for venomous snakes. You require to have care for these production animals, mainly horses, and also you require to have a laboratory where you are going to process the blood samples of the animals to produce the antivenom. So this is something that is expensive, although antivenom is effective, it has limitations as it doesn't always reach where it is really needed. So vulnerable populations become unattended. So in Colombia, we have around 320 snake species, but only 51 species are venomous, right? But of these 51 venomous species, these two species, Bothrops asper and Bothrops atrox, which are pit vipers, cause most envenomings, right? They cause between 60 and 80% of total envenomings. In the country, we have around 5,000 yearly reported cases with at least 50 yearly reported deaths. So it's something like 1% of case lethality caused by a snake bite if people go to medical centers and get antivenom. If we see the distribution of hospitals with the capacity to deal with a snake bite in Colombia, we can check that in several areas we have hospitals that have to cover huge areas and people will have to travel long times to that hospital. In addition, distribution became challenging, antivenom distribution became challenging. So, for example, in 2017, if we look at the severe cases, which are cases that put in risk the life of the patient, the 13% of these cases people didn't get antivenom. And as a consequence, people are dying because, not because we don't have antivenom, but because we are not being capable to make this treatment available for vulnerable populations. So people do the most difficult part, that is arriving to a medical center from their communities, indigenous communities, rural communities. But when they arrive the medical center, they don't have antivenom and people die in these hospitals. So, in this kind of problematic, the World Health Organization developed a global strategy that aims to reduce snakebite mortality and morbidity by 50% by 2030. They developed four strategic aims, and we are going to focus on the third aim, that is a strengthened health system. And to strengthen health system, we need to improve the information regarding epidemiology of this problematic. And to start doing this, given that we don't know so much about the biology of these venomous animals, we have to start trying to model, to mathematical modeling, these kind of diseases. So the first thing that we wanted to do is, okay, can we model a snakebite as an infectious disease? And to do this, we tried to implement the law of mass action that is widely used on infectious diseases. This law states that the incidence, the new infection, will come from contacts between susceptible and infected populations, and these contacts are going to be modeled as the multiplication of the abundance of susceptibles and the abundance of infecteds. In a snakebite, it is not an infectious disease, but we know that new cases of snake bites will be caused by contacts between susceptible population and venomous snakes. So we can state that incidence will be proportional to the multiplication between humans and venomous snakes. But doing the measurement of venomous snakes abundance in field is really difficult. So we went to Costa Rica. Why Costa Rica? Because this country has law on reporting. The Instituto Clomiro Picado is a pioneer dealing with the snake bite. So it's a perfect country to start working with mathematical modeling to test these models. And there we tested this law. So in this plot, for each municipality in Costa Rica, we know S, that is the rural population, and F, that is a proxy for venomous snake abundance that we developed in field. So we went several nights during 1 year in different places of Costa Rica to search for venomous snakes during nights, and we performed this kind of venomous snake census. And when we multiplied both variables and compared it with the reported incidence, we got this linear relationship that is telling us that the law of mass action is working on a snake bite. So now that we know that this law is working on a snake bite, let's try to apply it to understand underreporting in Colombia. In this work, first, to estimate the abundance or the proxy of venomous snakes abundance, we did niche modeling, species distribution modeling by entropy maximization for the both species that I told you that cause most envenomings in the country, right? So when we got these maps of the suitability that we called a snake niche modeling score, and we compared these results with the reported snakebite risk, we got another nice linear relationship that is telling us that the law of mass action is working, and also that SNFMS, the results of these distribution models, are a valid risk estimator. So we got this risk estimator, and to estimate underreporting, what we did is to get an accessibility score that we computed it as the average travel time in each municipality, travel time from each part of the country, and each hospital with the capacity to deal with the snake bites. So we developed by geographical information system tools this map of travel time to nearest medical center, and we mixed this data with data of poverty that we use the unsatisfied basic needs. And with all of this data, we calibrated a generalized statistical model that estimated underreporting, the percentage of cases that are not being reported in each municipality in the country. We got that the national underreporting is around 10%, 500 cases that are not reported, that it may not sound so alarming, but if we assume that these cases that are not getting reported will not receive antivenom, and we assume a mortality rate, a lethality rate of 10% in these cases, we will have that on the reporting of deaths will be around 50%. So practically in terms of deaths, we are only collecting the half of the information of the total panorama in the country. These behaviors that we found here are affected by the distribution of the venomous snakes, and it depends strongly on climatic variables. So climatic change will affect snakebite dynamics, and we could not be prepared. We will have venomous snakes in areas where before we didn't have venomous snakes. We will have some areas with more abundance of venomous snakes. So the risk will increase, the cases will increase, and if today we are not able to distribute antivenom correctly, we will have problems. And then what we wanted to do is to understand how does temperature and rainfall drive snakebite temporal patterns. So to perform this, we use like the framework that is that in Costa Rica, in this work, they found a relationship between rainfall and snakebite incidence, and they explain it by the reproductive phenology of venomous snakes. So if you see at the right panel, you can see that births of newborns of new venomous snakes occur close to the rainy seasons in the Pacific and in the Caribbean of Costa Rica. But although we have the same venomous snake species in Colombia than in Costa Rica, Botrops aspect, you can see that the populations that exist in Costa Rica are totally different than in Colombia. So we cannot assume that we will have the same behavior. We perform a model based on partially observed Markov processes, where we have a process model based on the law of mass action, and we develop a measurement model based on a Poisson process, and we adjust this model by using covariates of temperature, of rainfall, and of seasonality that was not driven by any climatic variable to check which variables are contributing in each part of the country. So nationally, what we found is that rainfall drives snakebite incidence, right, as you can see in the upper panel, but maximum and minimum temperature don't. And this is because we're in a tropical country where annual temperature is quite constant. For example, in temperate areas as in the North American continent or in Europe, we can expect that temperature will drive snakebite incidence. But when we start looking for different regions in the country, what we found is that regions with high rainfall, snakebite incidence is not driven by rainfall, right? We found only in this region too a seasonality on snakebite data, but this seasonality is not explained by rainfall. But if we look at these other areas of the country where we have marked dry seasons at the beginning of the year, what we can see is that rainfall drives snakebite incidence. Why do we have this complex pattern? We don't know, because we don't know information about venomous snakes. It may be caused by reproductive cycles, it may be caused by changing activity patterns, not only of venomous snakes, but also by humans and farmers. But to start like filling this knowledge gap, we create Botroperio Research Group, where we are trying to generate novel information about venomous snake biology. And I want to talk briefly and quick about these three people of the group. First is Jorge. Jorge is a local farmer who has helped us a lot, and we have learned together a lot about venomous snakes. So it's really beautiful to have this relationship with people from the community. And Sophie Nata, who are the first graduated persons of this group. So, for example, in Nata's thesis, what we did is to try to understand how does vipers move. And we did a technique that is based on a bobbin thread, where we attach the bobbin thread to the snake, and then we follow the thread that the snake leaves on while it is moving. And with this, we can estimate home range, territory, movement rates, and we want to start doing this estimation during dry seasons and rainy seasons to determine if the relationship that we saw previously is caused by an increase in activity patterns. We found that Bigger snake, SBL is the measurement of the large of the snake, and the weight is the weight of the venomous snake. We found that bigger snakes has larger home range, so they will be more prone to reach human areas, but we have to perform more research in that part. And finally, Sophie thesis tried to understand how does this animal perceive us, and we based this research on thermoreception. Why on thermoreception? Because pit vipers are called pit vipers because they have this loreal pit that is a specialized organ that they use to see temperature. Practically, they see temperature with this kind of organ. So what we did was an experiment to determine when are these vipers having an attacking reaction of an experiment. So I'm going to show you two quick videos. I'm going to put this smaller to don't see all the video. You are still looking at the slides, right?
Yeah.
Perfect. Thank you. So in this case, we have this is the same individual that I'm going to show you later. This individual of venomous snakes has the eyes uncovered, is totally looking around and totally with all of the perceptive organ open, and we are passing this thermical plate at 38 degrees to check what is the reaction of the snake to this plate. This was done during the day, and if you can see, the attitude of the snake is really neutral, right? Now, when we do the same experiment with the same individual of a snake during night, right? And here we did something really interesting, and is that we covered the eyes of the snake. So the snake is not looking anything. It's only using thermal information. During the night, look the difference of the behavior. First, look how the snake follows the stimuli with its head. It is using his tongue to detect like what is happening, what is that. It's really reactive, and after that, it starts attacking. Right? And look that the attacks are really directional. A snake has a really stressed pose, is not comfortable with that stimuli, and that's what happened before a snake bite. Let's remember that we are mammals, we have temperatures close to these 38 degrees. So what we can see here is that during night, these animals become more responsive, so the risk will be higher. Another important thing is that we only registered attack reactions with the thermal stimuli of 38 degrees. So, final remarks. Snakebite dynamics will change with climatic change. Global warming will increase distribution areas for venomous snakes. Rainfall patterns variations due to climate change will change snakebite dynamics. We don't know how these changes are going to be because we don't understand venomous snakes, so it's time to start prioritizing studies on venomous snakes ecology. So thank you very much for being here, and I will be open to questions in the next section.